Hey everybody, let's give these two problems a try. They're similar, they use the same picture. Okay, so first, we're neglecting the weight of these bars. And then we're trying to solve for the friction over here and the coefficient of friction. Okay, right, so notice that this is like a wall, and then this plate is like leaning against the wall. So it's just friction holding it there. Right, there's a wall like this. Okay, so if there's, let's see, there are these two bars like this. If there is no weight, we're neglecting the weight of the bar, then there's only force acting here at point C, here at point A, here at point A, here at point B. So they are both two force members, which means it's either like this one's in tension or it's in compression. Those are the only possibilities. And then this one is either in tension or compression. So because they're only axial forces, we could, if we want, basically just use the method of joints. Right? So then, say at joint A, looks like, let's see, here, here, here. Okay, so I drew the axial force in tension for member AC. I drew the axial force in tension for member AB. And then there's weight here, which, okay, so we know the mass. So M is 6 kilograms. And there we go. Okay, and then joint B, let me just jot it down over here. Looks like, so I drew this in tension, so I'll draw member AB in tension. Okay, and then there is a normal force, normal to the wall, so like this, normal to the wall, and then friction parallel to the wall, and then you just think which way is the friction. So this plate is going to want to slide down. So there's got to be friction opposing the motion. And then we're looking for the static friction. So this is static friction. Okay, so there we go. Let me pick some coordinates. All right, and then let's take a look. We know the angles. This is 8 degrees. Over here is 30 degrees. And this was 8 degrees. Okay, so let's write some equations for these. Okay, so then for joint A, I see that there are 2 unknowns. Joint B has 3. So I would prefer to start where there's less unknowns. So in the x direction, minus TAB cosine 8 minus TAC sine 30. And that's it. In y direction, TAC cosine 30 minus TAB sine 8 minus mg. Okay, so 2 equations, 2 unknowns, so you can solve. For example, let me make some space over here. Okay, so for example, just pick one or the other. Let's say AB is minus TAC sine 30 over cosine 8. Take that and plug it in right here. All right, so if I did that, this equation would turn into TAC cosine 30 minus TAB, which is all of this. TAC sine 30 over cosine 8 times sine 8 minus mg equals 0. So look, there's only this one unknown in this equation. So just factor that out. TAC, okay, let's see what we have. Cosine 30 plus Okay, so we got sine 30, sine 8 over cosine 30. So that's sine 30 times tangent 8 equals, I'll move this to the other side, mg, and then this whole thing goes in the denominator, and then you got TAC. Take that answer, so solve this for TAC, plug that in right over here. Now you have TAB. Okay, so at this stage we have both of these answers, which means we know this one over here. So over here, TAB, that's known. Okay, so then let's write two equations over here. So x direction, we got n plus TAB cosine 8. That's it. Okay, y direction, static friction plus TAB sine 8. All right, so then again, we already know TAB. So then just plug it in right here, solve for n. Plug it in right here, solve for Fs. Okay, and then let's see, part A. Okay, so once you solve for Fs, the static friction, that's part A. What's the coefficient of friction? So just, there's one more equation. Friction is less than or equal to mu s times n. Right, so if you're looking for the minimum, then that's where, instead of less than or equal to, that's exactly where it's equal, because that would be the maximum possible static friction. Okay, and then just solve this. So just F divided by N, and then that's part B. Okay, next, this one, number 58. This time the bars we're considering to have mass. So that's different. If they have mass, the free body diagram of each bar, right? So before we were saying there's only force acting here at B, here at A, here at A, here at C. That's no longer the case because the bar has weight. So now there's weight acting at the center of mass of each bar. So whatever, let's see, they're given, right? Yeah, 3.6 and 3. Okay, so this is given. Mass AB times G, that's the weight. Mass AC times G, that's the weight. Okay, and then all the other stuff. So here is C. So there's that pin over here at C. All right, so I'm just decomposing the reaction at the pin C. And then over here, that's where there's the normal force and static friction. And then at joint A, these forces have got to be, if I decompose this reaction, they have to be equal and opposite over here, right? And one last thing, the weight of this. Where does it go? It goes either here or here. You just pick one or the other. Only one, right? Just not both. And whatever, that was 6 kilograms, right? I'll just call it mg, where m is 6 kilograms. Okay, so this is basically a frame that you broke apart, right? That same method you've done before. Okay, so let me move these around so I have more space. Okay, so for this member, all right, let's write some. So for the forces, x direction, we got AX, CX, that's it. Y direction, AY, CY, minus mg, that's the 6 kilograms, this one. And then the weight of the bar itself. And that's it. Okay, now for this member, in the x direction, we got n. Okay, and then this was at some angle, right? 8-degree angle over here. And this was at a, was it 30-degree angle? Yeah, 30 degrees. Okay. All right, so x direction, n, minus ax. That's it. Okay, y direction, f the static friction minus AY minus M, the weight of the bar. Okay, now we have so far 6 unknowns: AX, AY, CX, CY, and friction. So the unknowns that both have in common definitely are AX and AY, because it shows up in both places. So I would like to have those as unknowns. So for this bar, I'm going to sum torque about point C so that the unknowns will be AX and AY. And then my strategy for this one, I'm going to sum torque about over here, which I think was point B, right? Yeah, point B. Point B, because then the unknowns will be AX and AY. So these two equations will be in terms of AX and AY, which means I'll have two equations for two unknowns. Okay, so let's do that. So some torque about point C. So nothing from these two. Here's the weight. So here to here is, okay, how long is this bar? It's known, LAC. So here to here is half of LAC times, it's opposite the angle, right? So sine theta, sine 30 degrees. Right, that's this distance right here, times this weight, and that would create a torque going this way, which is actually in the negative z direction, so I'm going to put a minus sign here. Okay, now what is the torque from this force over here? Here to here would be the length of the bar times sine 30. So LAC sine 30. Right, so that's here to here. And then times this force AY. And that would create a torque this way, which is in the positive z direction. And then the torque from this force is here to here is LAC sine 30 and would create a torque going in the negative direction. So it's the same, but then with a minus. So just factor those together like that. Okay, now what is the torque from this force? So here to here is how far? LAC cosine 30. So LAC cosine 30 times this force, and that would create a torque this way in the positive direction. Okay, so these three equal 0. There are two unknowns here, AY, AX. Okay, now let's move on to this one. So let's sum torque about point B, which is over here. Okay, and then let's see. So this bar was AB, right? Okay, so the length of this bar is LAB. So then from here to here is half. So from here to here is LAB half, and then it's adjacent to the angle, so cosine 8. So that times this force, the weight of the bar, and that will create a torque going this way in the negative direction, so minus. The torque from this also in the negative direction, so minus, and then here to here, LAB cosine 8 times AY, and then the torque from this force would go this way, plus, and then here to here is LAB sine 8. And times AX. So those three equals 0. Okay, and then here are the unknowns. So once again, you have these two equations for two unknowns. So then you just pick one or the other. Let's see, maybe this one looks like it has a little bit less stuff. Right, so then let's say you solve for AX. So AX would be these. Okay, already I can see that I could factor, see, LAB is non-zero, so you can divide both sides of the equation. And then there's a cosine over here, so we have AY, and then there's a half over here. This times cosine 8 divided by this sine 8. So cosine over sine, I'll just put tangent. Okay, so this is AX. Take that, plug it in right here. So then what you have is an equation in terms of only AY. So solve for AY. And then take that value, plug it back over here. Then you solve for AX. So now you have both AX and AY. Take AX, plug it in right here. Then you have CX. Take AY, put it here. Now you have CY. Take AX, substitute it right here. Now you have the value for N. Take AY, plug it in over here. Now you have friction. And then finally, you know that friction at most is mu S times N. So the minimum value for the coefficient of friction has got to be this. Okay, so hope that was helpful. Let me know if you have any questions, and I'll see you in the next video.